For the second set of notes on section 9.2, I'd like you to work through the following example problems on your own. Pause the video, work through the problems, and once you're ready to compare your answers with mine, you can hit play. In number 1, we're given we have a circle with center T. We know that the measure of arc NR is 50 degrees, the measure of arc GR is 90 degrees, and the area of the entire circle is 36 pi. I'm marking the measure of arc NR here, and the measure of arc GR right there. We first want to find the measure of arc GN. If we think back, when we see measure, we should be thinking about the number of degrees that the arc occupies. So this blue arc here must be 40 degrees. And that's our answer for part A. For part B, we want to find the length of this arc now. When we see length of arc, we should be thinking about the fraction of the circle's circumference. If we look at that blue arc there, it's part of the circle's circumference. So we only care about that fractional piece. How do we find the circle's circumference? We find the circumference of the entire circle by doing 2 times pi times r. But we only care about finding this fractional piece, 40 degrees out of 360 degrees total, since every circle occupies 360 degrees. We don't have our radius yet, but we are told that our area is 36 pi. So we can substitute that in for A in our equation and set that equal to pi r squared. Dividing both sides of the equation by pi, we're left with 36 is equal to r squared, and taking the square root of both sides of the equation, we're left with a radius of 6. So we can now substitute that in to the formula to find the length of the arc. So we're doing 2 times pi times 6, and then I reduce the 40 divided by 360 into 1/9. So we multiply across the top, which leaves us with 12 pi divided by 9. And if we reduce that fraction, we're left with 4/3 pi is the length of the arc. Moving on to number 2, we want to find the area of the sector KMS, which is right here. We know the radius of the circle is 3, and the measure of the arc is 130 degrees. When we see area of sector, we should be thinking about the fraction of the circle's area. So we care about 130 degrees out of 360 degrees here. We find the area of the entire circle by doing pi r squared with a radius of 3, which leaves us with 9 pi times 13/36. Let's multiply across the numerator, which gives us 117 pi divided by 36. We can leave our final answer as an improper fraction. I included units squared on the end of the answer since we're talking about area. You'll learn more about that in a later chapter. Last but not least, for number 3, it said if we were to look ahead to chapter 10, we would discover that the measure of an inscribed angle, which is right here, is half the measure of the intercepted arc. The inscribed angle always has its vertex on the circle itself. You'll learn about that in chapter 10 again. But we know that the angle is half of the arc, so I'm just writing a general equation there. Our angle is represented by 4x, and our arc is represented by 6x plus 22. So we're setting our angle equal to half of our arc. Distributing the 1/2, we're left with 4x is equal to 3x plus 11 to get that x has a value of 11. But since we want to find the measure of the inscribed angle, MAT, we could substitute 11 back in for x to get 44 for the final answer. For the problems in this section, you may also have to recall the midpoint formula, the slope formula, and you may come across some problems that deal with reflections or transformations. If you'd like to see further examples, you can refer to page 373 in your textbooks.